anyone that's going into developing programming, as far as being a basic individual. And sure, you don't have to be basic on the sense of programming in general, but just the logic behind it, right? So we're thinking more of how to structure, how to use and apply certain techniques in programming that are related to mathematics. And if you have a basic understanding of math, well, cool. Well, a great place to start. If you don't have it, well, you're about to get it. So it's kind of like two birds in one stone, where potentially, if you've essentially gone through algebra 2, maybe you didn't pass with flying colors, that's all right. We're going to go over some concepts in mathematics that'll help individuals with programming, um, the concepts that lie between how to manage information, like variables, data, and most importantly, functions. And we'll go into object orientated as well, which generally speaking is not a very big necessity. It's just one of those recommendations to clean up and work with your code. So generally, you don't really have to use object orientation, but in the professional environment, it's definitely a must. But if you're coding for yourself, you're creating your own applications, your own work, it's useful to understand it, even if you don't apply it. We'll start with what we did last time, going over just the parallels between your basic 15% of all languages, which includes variables, functions, logic, looping, and objects. Understanding how those work not only help you use other people's libraries of code, APIs, and other factors, but it helps you essentially work with the logic behind how to structure an application in a general sense. I was setting up a little workspace, workbench, if you will, for the stream that we'll be using on a regular basis. And we're going to continue from there, but let's take a look at these details here. Basically, in mathematics, you've got variables, x, y, z, LMNOP, whatever the case may be. I'm a poet, didn't even know it. But the reality is that they are just what I like to really consider any variable in the mathematical sense. If I can find the where did I put my pen? I had my pen somewhere. Now it's gone. Well, that's not the first. Let me use this other pen. So, damn, where did I put my pen? I hate when things just disappear. Oh, there you are. It's just a black pen on a black phone being camouflaged. When I think of any variable, let me see, kind of going over here. Let's say we say x is equal to 5. Before we even introduce variables to students, we started off as an unknown, which in essence it is, until we start giving you some plugins to work with. So when we ask the question, what is 15 plus something equal to 10, your brain starts firing trying to fill in that piece of information. This is just a logical troubleshooting method that the brain does. Trying to see, is it 1, is it 2, is it 3, is it 4? In fact, I should probably be doing a negative. I may make it simplified. I was going to do a negative number in there, but like this, just to keep it simple. We're essentially going to be thinking about, all right, what number can I add with 15 to get my 20? Well, that variable in itself, you can kind of plug in mentally, and it's going to be the number 5. So the way I look at variables is just a box of data. The X that we use in our vocabulary in the alphabetical sense of things, a symbol that represents a letter. And this is where a lot of students in math get tripped up, like what's going on? Why are we now using letters and numbers, right? But it's not like we're using them in the same format. There are some rules that apply in a mathematical sense because this X, in essence, is a box. It's a location of space, and we put a little label on this box, call it X, so we can recognize the differences between a box over here and a box over there. That box is X, that box is Y. We only label them to distinguish the differences between certain parts of our equation, especially when it comes to functions, which we'll see in a little bit. So when we think of any sort of variable, just think of it as a box of mystery, a mystery box. And when we state the directness of x equals to 5, we're telling you explicitly that this box contains 5. In fact, when you use x and any part of this problem equation after we've stated this little detail, it just means that this box contains the number 5. This is how variables work in programming. Although we don't necessarily stick with just the um, simplicity of a single letter variable, we basically use it in the form of let's name something specific so we know how to access that thing in the future. So this is where we go over here and say, all right, in programming, you can use x equals 5 if you'd like. You can also use number x or num x to specify. Or if you're not even using numbers, let's say the color of a specific character, you would use hair color. This would store the information. So we're kind of dealing with a sense of different data types. In math, we've only got numbers as far as data, as far as usable factors. But in any other format in programming, we obviously have way more than just numbers, including decimals and integers. But we have true and falses, what we would call Boolean. We can call it Boolean value and then call it true. Some languages use capital T, some use lowercase t. It all really depends on the language you're using. But the fact is that it wouldn't be any different than saying Boolean number equals to 1. They bear the same results because if we really reach back to the focus of how a program even works, it's zeros and ones. It's all the way back to something turning on or something turning off, all the way down to the basic components of a circuit board. A specific path is judged by where all the ones are, and we're just following that process to get to the end result, which is turning on the device or turning it off. So we kind of simplify this idea where 1 is true, 0 is false. And preparations into college, calculus, physics. I love science, so we can talk science all the time too. Um, and yeah, you can find me on Patreon. You can subscribe and like and follow, depending on where you are, for more of these enlightening informational videos. And feel free to join me anytime I have my sessions. You can get to see the cat once in a while, Mr. Shadow over here. And you can come and chill, ask questions, and enlighten your thoughts, enlighten your logic, get them brain cells working, and learn new skills, real life skills. We can all play games all day, but what do we get from those? Not much. Make sure to like and subscribe. I've got more and more on a daily basis. I'm gonna try to do every day. Generally speaking, I might not be able to because I do have students I have to tend to. You can find me again, Patreon. You can find on Super Scholar Chris MIA. You can look up on Google or Bing or Yahoo, Christoph Tutoring or Christoph with Chris MIA. Also follow me on X if you are on X. You can basically find most of my links here at the bottom. This little thing over here, flipping around down there. That's a little JavaScript animated space I've created. So it informs me of what I do. You can find me right there on Patreon. Is that the one? Yeah, or Super Scholar. Actually, that'll take you directly to my Patreon too. So Super Scholar to XYZ. I did have. Anyway, thanks for joining.